Ideally, PCBs should be perfectly flat. However, this is not always possible. Bow and twist usually occur. PCB bow and twist are two common types of board warpage that can occur during and after the PCB manufacturing process. PCB bow refers to the warpage of the board, which causes it to have a convex or concave curvature along its length or width. PCB twist, on the other hand, refers to the warpage of the board in a rotational sense around its center, causing the corners to no longer lie in the same plane.
You might be wondering why balances are important and what problems they can lead to. Let's discuss that.
Bow and twist can cause inaccurate positioning during assembly, which makes it difficult to accurately place and secure components into the board's holes and pads, or even cause a collision between boards and the automatic insertion or placement machine during the assembly line. On the other hand, bow and twist in PCBs can cause signal integrity issues and mechanical stress, leading to performance degradation and potential component failure over time.
Well-designed and properly manufactured PCBs will not have excessive bind twist. So, what are some factors that can contribute to the occurrence of bind twist in PCBs?
Several factors may contribute to the occurrence of bow and twist. The presence of large copper planes or traces concentrated in specific areas of the PCB can lead to uneven thermal expansion and contraction. Since copper and dielectric materials have different coefficients of thermal expansion, which means they expand and contract at different rates when subjected to temperature changes. When a PCB undergoes thermal cycles during manufacturing or soldering processes, the areas with more copper will heat up and expand differently than areas with less copper or no copper. When the layers in a PCB are arranged asymmetrically, with varying thicknesses of the individual layers, materials, copper weight, and core thickness, it can create internal stress within the board that can lead to bow and twist over time. Suppose we have a 6-layer PCB with the following layer stackup. In this stackup, the copper weight on the ground plane is much higher than that on the other layers, and the thickness of the power plane is much greater than that of the signal layers. This kind of stackup may increase the possibility of warpage. So, one of the balanced stackup can be adjusted like this. In this adjusted stackup, the copper weights and thicknesses have been balanced across the layers. Other factors such as board pressing parameters for multi-layer boards, material selection, and component placement can also cause the board to warp.
If a PCB exhibits some degree of bind twist, is it still available to use? And if so, what are the acceptable levels of bind twist tolerance in PCBs?
Despite the risk of bow and twist, PCBs are not completely flat in practice. IPC 6012 provides guidelines for acceptable levels of bow and twist in PCBs. For boards using surface mount components, the bow and twist shall be 0.75% or less. For other boards, the maximum allowable bow and twist is 1.5%. To ensure that our customers receive PCBs that meet their exact specifications and perform reliably, PCB specifies bow and twist tolerances for the processing of PCBs with varying levels of production difficulty.
Any tips that can help us minimize the bow and twist?
To minimize the risk of bow and twist in your PCBs, it's important to carefully consider your layer stackup design and copper distribution. Proper handling and storage during and after manufacturing can also help prevent bow and twist. Additionally, using a suitable PCB material with a lower coefficient of thermal expansion can help minimize the effects of thermal stress on the board. By taking these steps, you can help ensure your PCBs remain flat and stable over their lifetime.
What other strategies have you found effective in reducing bind twist? Share your experiences and insights with us.